Next protocol is called as IPSec, that is Internet Protocol Security. Internet Protocol Security is a set of protocols that is developed by the Internet Engineering Task Force, that is IETF, for encryption and authentication of TCP/IP traffic. This IPSec provides cryptographically based authentication, integrity, privacy services. This IPSec provides security services at the IP layer. That is the important point here. It gives the security at the IP layer. That is network layer. Now, in network layer, we are transmitting the data in the form of data packets. These are traveling in the internet in an unsecure manner. Whenever you are using unencrypted packets, the opponent can hijack that one, forge that one, as well as modify that packets for receiving the receiver. So you have to provide some security to that packets which is transmitted in the network. So that can be provided by protocol called as IPsec. So this IPsec protocol provide a security at the network layer, which is at the lower part of the website model. So we can use this IPsec with any type of application. There is no any specific application on which we can use this IPsec. It is transparent. You can apply this protocol for any type of application. Now, what are the uses of this IPsec protocol? Some of the applications here. Now, if the company want to build some secure virtual private network VPN over the internet or over a public WAN, because the internet is not secure one. In that internet, we have to create one secure network, that is VPN. This enables a business to rely heavily on the internet and reduce its need for private networks. Whenever a separate network is created by some company, they have to invest. So making they have to pay for money, or they have to invest something. So to overcome that one or save cost and network management overhead, we are using the internet. In an internet, we are providing some secure channel with the help of IPsec. One more application is nowadays, due to some coronavirus, the pandemic situations, most of the employees and most of the customers are dealing with the organizations or company from home. They are working from home. It gives some security. Whenever they are connecting to the network of the organizations, company, company network, there is a security for that network. All the employees are using the internet for their company network, accessing the company network. So that type of security will be provided by IPsec. They have to install, they have to configure the internet service provider. Sorry, they have to configure this IP security over their computers. The next application is IPsec can be used to secure communication with other organizations. If two organizations want to communicate for business purpose, and they have to authenticate, they need some authentication, confidentiality, and key exchange mechanisms in secure manner. Two sides want to communicate with in secure manner. In that case, we are using IPsec. Like that, there are many other applications where we can use IPsec protocol for security purpose. In IPsec, we are using two types of protocol. Two protocols are used to provide security. The first one is called as Authentication Header, also called as AH. The second one is called as Encapsulating Security Payload, that is ESP. In a key concept that appears in both the authentication and confidentiality mechanism for IP is the Security Association, that is SA. Whether we are using authentication header, whether we are using ESP, both the cases, the key point you have to remember there is called a security association. First, between the two parties who want to communicate, between that, the security association will be created. Now, what is the meaning of security association? Now, security association means a contract between two parties. It creates a secure channel between two parties. It's a logical relationship between two hosts here. Okay, for example, here, if the Alice want to establish an IP connection with the Bob, the two parties must first negotiate a set of keys and algorithms. That means what type of algorithms they are using for encrypting authentication, what type of algorithms they are using here. That negotiation has to be done. If any symmetric algorithm is used, what type of secret key they are using. If public encryption is used, what type of private key, public key they are using. Such type of sharing will be done between two parties here with the help of SA. The concept of security association is a mechanism for this purpose here. Here, this SA will be established between two parties only for one session. And for encryption, there is a separate SA. For authentication, there is a separate SA. Means one SA is not used for both authentication as well as encryption. So this is called a security association. This security association is created by using some of the information provided in the header of the AH or ESP along with the destination address of the host. Now, first I will explain here authentication header. This authentication header provides a connectionless integrity in data origin authentication for IP datagrams. Now, this AH will provide authentication header. This AH is only used for authentication purpose. It is not used for confidentiality. If you don't want to protect your data from eavesdropping, then better technique is use authentication header. The authentication header provides connectionless integrity and data origin authentication for IP datagrams. This is only used for authentication purpose. It also optionally provides protection against replays. The opponent cannot replay the same packets again in the later stage. So it gives some optional protection. It is depending on the user requirements. Okay, optional protection will be given against replay. Here, this authentication header will provide both type of IP, that is IP version 4 as well as IP version 6. Here, this header will be authentication header will be attached with the both versions of the IP. Now, the authentication header will be look like this way. This is the diagram. Now here each block is actually, here it is into 32-bit. Header is divided into multiples of 32-bit. Now the first part of this one is called as next header, which is a 8-bit header. This next header field identifies the type of next payload after the authentication header. That means after this header part, what may be the next header contain? What type of header it contains? For example, this authentication header as well as ESP works in two types of modes, transport mode as well as tunneling mode. In both cases, the embedding of this header will be different, which I will explain in the next part here. The next header field tells you what is the next header after this AH header. That is explained by this first part, 8-bit code. The next part indicates payload length. This specifies the length of the AH in 32-bit words. What is the length? What is the length of the payload? That is explained by this payload length. This specifies the length of AH in 32-bit words. That is nothing but 5 byte minus 2. Here minus 2 because I am not considered this reserved as a part of AH here. So it is minus 2 here. The number of bytes used by the payload length. The next one is called as reserved field. This part is called as the 16-bit field is called as reserved field. It is used for future use and initially it is set to 0. Here when this authentication header is designed, this part is designed, the developer or the designer thinks that in future they may create the different versions of authentication header, that is updated version of this authentication header. So in future maybe they need additional header parts. For that one they reserved some space in the heading part. The 16-bit is used for the future extension, but this is never happens. It is never used till now. So it is a 0. The next one is called a security parameter index SPI. This is a 32-bit value. Along with this SPI, we are using the destination IP address to uniquely identify the security association for this datagram. As I told, the important keyword is called as security association. Whenever two parties want to communicate with each other, first they will establish a security association by providing the destination address as well as the security parameter index. Whenever they use these two parts, they create one unique address, uniquely identify. For example, if you want to identify in college there are many students and you want to uniquely identify, you already given some roll number. Now what we are doing here, we are identifying each one of you by using the branch like CS and the semester like 4th sem, CS, 4th sem, and your roll number. Whenever we have such type of data, we can uniquely identify that it's you. In similar way, in security association, we can easily identify with the help of this SPI and destination address. Next one is called a sequence number. Sequence number is a monotonically increasing counter or sequence number is used for protect against replay. This part is used for protection against replay attack. Now initially its value is set to 0. Whenever you start to sending some message or data is divided into number of blocks. The first block sequence number is given as 0. Whenever you deliver the first block to the destination, its sequence number is initialized to 0 and it is counted. Whenever you send the second frame, it is 1, third frame 2, like that. On each frame, this sequence number is incremented by 1 and the maximum sequence number should be 2 raised to 32 minus 1. Means I can send the sequence number should be start from 0 to 2 raised to 32 minus 1. If we have to send some more frames, then I have to restart from 0. For that, the SPI value should be changed here. Means I have to create a separate security association. Then the sequence number started should be 0. That means for one security association number, I start from 0 to 2 raised to 32 minus 1. If I want to send more information, I have to change the security association number. That is nothing but here SPI number here. Now the next one is for authentication data field here. This field is actually variable length field. It's not a fixed size and it contains some integrity check code such as CRC. We are using some message integrity code here to check whether any modification is done in the payload or not. The data is modified intentionally or automatically during the transmission. That can be done by this field, that is authentication data field. So this AH will provide both authentication as well as integrity check. Next one is called as encapsulating security payload, that is ESP. Here ESP will provide both type of security, that is confidentiality as well as authentication as well as data integrity. Your AH will provide only authentication and data integrity, but here it will also provide confidentiality. Means whatever the data you send is not visible to the opponent hacker. One of the most popular way of use this ESP is to build an IPSec tunnel between two routers. I already explained that our protocol can work in two mode, transport mode as well as tunneling mode. Tunneling mode will provide a little bit more security. ESP header is designed to provide a mix of security services in IP version 4 as well as IP version 6. Here also it will provide the both versions of IP. The ESP header is inserted after the IP header and before the upper layer protocol header, or before an encapsulated IP header when used to tunnel between the pair of security gateways. Now, what is the meaning here is I can add this header information. This is the diagram for ESP header. Now, this header can be added to your IP frame. Now, how actually it is added? Now, this is your original IP packet, which contain IP header information here and TCP header information. Okay, this is the upper layer header information along with the data. Now, this AH or the ESP header is added EH or ESP header is added after the IP header. If you are using transport mode, if we are using the tunneling mode, this ESP header, sorry, EH header or ESP header is added between the IP header as well as the new IP header. This is the original IP header, is which contains the information of original destination as well as source. But here it contains the destination of the next node where this processing will be done. It's not the destination of the original host, it's the destination of the next node where the processing of this packet will be done. So that is the virtual one here. So such type of feature will be provided. Here is embedded between like this. This AH header, ESP header are embedded in the IP packet in this format. Now I will explain this ESP header. If you see properly here, ESP header is almost have the same field as the EH with little bit additional fields. The first one is called here security parameter index here. The first we have SPI. You already know that. What is the use of this SPI? Its function is same as the AH. For example, it's used to identify the security association along with the destination address. Next one is called sequence number. This sequence number is used to protect against replay attack. Here the next one is we have payload data variables. Here we are having data, that is actual data we have to transmit along with the user's requirement whether encrypting or not. Sometimes this payload data is encrypted format, sometimes it is not encrypted format. It is depending on the user's requirement. If user want the confidentiality, he will encrypt this payload data. After that one we have here next one is here the padding. The padding field indicates you have to encrypt this data. Sometimes you have to encrypt this payload data. But most of the encryption algorithms use the input as the multiples of some bytes like 32 bytes, 64 bytes. So we have to add some additional bits at the end of this payload data so that the encryption will be done improperly. So we have to add some additional bits before feeding the encryption for the payload data. And how many bits we are added here? How many additional bits are added to the payload data? That is indicated by payload length here. That is first pad length. Sorry, pad length will be explained how many bits are added here. Here the next header indicates after this header part, what is the next header comes? The IP framework. That is indicated by here the next header part. And the authentication data, this is a variable length field as I told in the earlier part. This contains the integrity check value computed over the ESP packet minus the authentication data field. So this actually contains the authentication code which is used for integrity check. Sorry, this contains some CRC check which is used for the integrity.